On June 22, 1940, the design team at Curtiss-Wright secured a government contract. They were led by the talented engineer Donovan Berlin. Their goal was to develop an ambitious new fighter known as the Model 24, or CW-24. Berlin set out to design an aircraft using a canard configuration. His concept featured a mid-mounted wing with a 35-degree leading edge sweep. On paper, this radical approach promised exceptional maneuverability and excellent spin characteristics. However, there was a major catch. Canard design suffered from inherent longitudinal stability issues. This was a flaw that could instantly negate all of the new fighter's advantages. The design team planned to equip the CW-24 with a powerful Continental IV 1430 engine, driving a coaxial pusher propeller. According to preliminary calculations, this setup would allow the fighter to reach an impressive top speed of over 506 miles per hour. This ambitious project did not emerge out of nowhere. It grew directly out of a formal Army Air Corps proposal known as Circular Proposal R-40C, issued on November 27, 1939. The document was drafted by Major Edward M. Powers, and it explicitly invited manufacturers to submit unconventional designs, provided they still delivered outstanding speed, climb rate, maneuverability, armament, and pilot visibility, all while keeping costs and maintenance needs low. Two other companies answered that same call with equally radical concepts. Vultee put forward a twin boom pusher fighter that became the XP-54. Northrop countered with a tailless flying wing nicknamed the Black Bullet, officially designated the XP-56. Donovan Berlin was hardly a newcomer to fighter design. Before taking on this experimental canard project, he had already built his reputation at Curtiss, designing the P-36 Hawk and its famous successor, the P-40 Warhawk, aircraft that would go on to serve American and Allied pilots across multiple theaters of the Second World War. Ironically, Berlin would not stay to see his radical new fighter through to completion. Frustrated by a lack of official backing for further P-40 development, he left Curtiss-Wright in December of 1941, just as the CW-24B testbed was taking to the skies for the very first time. The unconventional fighter program he had originated would continue on without him. Given the incredibly high technical risks, the team had to do extensive wind tunnel and flight testing. To test their concepts, engineers built a quarter-scale model of the fighter. They ran over 600 tests, and the results were alarming. It became clear that the pilot would face serious control issues. These were not just limited to the longitudinal axis. The model completely lacked stability in both the roll and yaw axes. The engineers' final conclusions after the wind tunnel sessions were pretty grim. They deemed the aircraft highly aerodynamically unstable. These wind tunnel trials had actually run from November of 1940 through January of 1941. Unlike a simple static model, the one used in the tests was powered. It was fitted with small motors that spun its propeller, letting engineers accurately simulate the slipstream blowing back over the wings and tail surfaces just as it would in real flight. As legendary aviation pioneer Orville Wright once noted, the pitch stability of a canard aircraft relies entirely on the skill of the pilot. Taking this to heart, Berlin convinced company management to fund a full-scale, manned experimental prototype. After all, a scale model in a wind tunnel could not provide real-world feedback. It lacked a live pilot in the cockpit to take the controls. With a flying testbed, the engineers could get hands-on experience tuning the flight controls. They could also optimize the placement and size of the rudders and dial in the rest of the aerodynamics. They designated this experimental aircraft the CW-24B. Army Air Force officials supported the initiative. They officially approved the aircraft's construction in November 1941. To save time and resources, they kept the design of the CW-24B as simple and lightweight as possible. The main fuselage frame was quickly welded together from standard steel tubing and covered in doped fabric. Meanwhile, the low-mounted wing was made entirely out of wood. About mid-span on each wing, they mounted a vertical fin and rudder. The wing was fitted with conventional ailerons and flaps. But instead of a traditional elevator, pitch control was handled by a forward horizontal surface. This was the defining feature of a canard design. The aircraft featured fixed tricycle landing gear. The gear did not retract. However, to cut down on drag, they enclosed the wheels in aerodynamic wheel fairings. The prototype was extremely light. Because of this, a small Manasco C-68 engine was more than enough for the initial test flights. It produced 275 horsepower and turned a two-blade wooden propeller. The main advantage of the bare-bone simplicity of the CW-24B was clear. Mechanics could modify the aircraft right on the flight line using standard airfield workshops. This saved a ton of time. They did not have to haul the airplane back and forth to the factory every time they needed a tweak. One subtle but important detail about this forward surface is that it was never meant to be a true canard in the traditional aerodynamic sense. Rather than generating lift on its own, the forward wing floated freely and only served to trim the aircraft for level flight. It could swing through an arc of 68 degrees both up and down, though this range was intentionally limited to just 17 degrees downward whenever the pilot lowered the flaps for takeoff. There was another quiet milestone buried in this design. Simple and fixed as it was on this early testbed, the tricycle landing gear marked the first time Curtiss had ever equipped one of its fighters with a nosewheel arrangement instead of a traditional tailwheel. Interestingly, the prototype did not carry any complex flight test instrumentation or specialized sensors. Instead, all the flight handling data had to be manually recorded by a second crew member, a flight test engineer. His workspace was set up in a small compartment right behind the pilot's seat. Two large observation windows were cut directly into the sides of the fuselage. This allowed the engineer to keep a close eye on the wing and vertical control surfaces in flight. Once the prototype was finished, it was carefully transported to the Army Test Center at Muroc Army Airfield. Its wide, flat, dry lake bed gave test pilots miles of open space to work with, room enough to recover from an unexpected departure from controlled flight without immediately running out of ground. This same stretch of California desert would later be renamed Edwards Air Force Base, eventually becoming the premier flight test center in the country. Then, on December 2, 1941, veteran Curtiss test pilot Harvey Gray took the unusual aircraft up for its very first flight. The pilot's initial feedback was actually pretty positive. The airplane flew well and responded nicely to control inputs. However, Gray immediately pointed out two serious problems. First, the engine was severely underpowered. This meant the top speed barely broke 180 miles per hour. Second, the aircraft suffered from noticeable directional instability during straight and level flight. This kicked off an intense period of test flights and continuous modifications. For 6 months, the experimental CW-24B averaged about one flight per day. To get the aircraft dialed in, the engineers were constantly experimenting. They changed the size and placement of the vertical fins. They also tested different sweep angles and added new aerodynamic fairings to the engine cowling. The work was relentless. By May 1942, they had managed to iron out most of the airplane's teething problems. They had finally locked in a stable aerodynamic configuration. All in all, the prototype logged 169 flights. To get the final verdict on its aerodynamics, the CW-24B was shipped off for full-scale wind tunnel testing at the NACA Langley facility. Among the most effective fixes to come out of this stretch was a change to the wingtip fins. Engineers enlarged them and shifted their mounting position about 4 feet farther outboard along the wings. This single adjustment noticeably improved the airplane's directional stability, addressing the very same weakness that had doomed the original wind tunnel model months earlier. In parallel with the ongoing testing of the experimental aircraft, all the successful engineering solutions were immediately rolled into the design of the actual fighter. On July 10, 1942, the United States Army Air Forces officially ordered 3 combat prototypes from Curtiss-Wright. They designated them the XP-55. Since the planned high-power Continental engine was not ready yet, the designers had to improvise. They decided to fit the aircraft with an Allison V17-1095 engine. This cranked out a maximum of 1,275 horsepower. Originally, the fighter was going to pack quite a punch, featuring 2 20mm cannons and 2 50-caliber machine guns. Curtiss assigned its new fighter the internal company designation Model 249C. The Army, for its part, issued serial numbers 42, 78, 845 through 42, 78, 847, to the 3 prototypes, numbers that would follow each individual airframe for the rest of its short service life. However, having to swap the engine for a less powerful version meant the aircraft had to shed some weight. To shave off those extra pounds, engineers shrank the fuel tanks and swapped out the heavy cannons for extra machine guns. On top of that, they ditched the complicated contra-rotating propeller system in favor of a conventional 3-blade variable pitch prop. One fascinating detail was the pilot bailout system. Since the propeller was mounted at the rear, the designers built in special explosive charges. In an emergency, these charges would instantly jettison the propeller blades. This allowed the pilot to safely bail out without getting struck. The man behind this clever safety device was W. Jerome Peterson, a design engineer at Curtiss-Wright, who devised the propeller jettison mechanism specifically to solve the unique bailout hazard created by a rear-mounted pusher propeller. On July 13, 1943, the first XP-55 was officially rolled out of the factory. Aerodynamically, it was an exact copy of its predecessor, the experimental CW-24B. Though at this stage it had not been fitted with any armament yet, the designers proudly named their new fighter the Ascender. At first, it was just a working nickname among the engineering team. But it caught on so well that it eventually made its way into all the official paperwork. Out on the flight line, however, the mechanics and pilots quickly turned the name into a joke. If you put a slight pause right in the middle of the word, it sounded like Ascender. This was a pretty clever nod to the unconventional placement of the engine and propeller at the extreme rear of the aircraft. Not everyone found the joke amusing. By some accounts, the nickname did not sit well with the Congressional Oversight Committee keeping an eye on wartime military spending, who felt it reflected poorly on such an expensive experimental program. Climbing into the cockpit was its own small ordeal, too. Because the fuselage sat so high off the ground on its fixed landing gear, pilots had to rely on a telescoping ladder that was stowed away just behind the seat, extending it out before every flight and stowing it again once airborne. Just a few days later, on July 19th of that same year, test pilot Harvey Gray took the XP-55 up for its maiden flight from Scott Field. The takeoff roll turned out to be unusually long. Gray was simply afraid to over-rotate during liftoff. He was worried he might accidentally strike the rear prop on the runway. Other than that, the inaugural flight went off without a hitch. To help the aircraft get off the ground sooner and shorten the takeoff roll, engineers decided to increase the area of the forward elevator by 15%. To make sure the airplane remained stable with this change, they made the flight controls a bit more complex. They did this by physically linking the ailerons to the flaps. Whenever the pilot deployed the flaps for takeoff, the ailerons would automatically droop by a specific angle, generating extra lift. However, on November 15, 1943, a routine test flight nearly turned fatal. It ended in the complete loss of the aircraft. Harvey Gray was testing the stability of the airplane when the engine suddenly quit. At an altitude of roughly 16,000 feet, the aircraft departed controlled flight. It flipped, inverted, and entered an unrecoverable flat spin. The emergency propeller jettison system failed to trigger, but the pilot got incredibly lucky. Because the airplane was falling almost vertically with practically zero forward airspeed, there was no strong slipstream to blow him back into the blades. Gray was able to bail out of the cockpit completely unhindered and safely deploy his parachute. The fighter itself was not so lucky. It pancaked into a plowed field and was completely destroyed. After thoroughly investigating the crash, engineers recommended extending the wingspan and increasing the pitch travel of the forward elevator. But they could not actually implement these critical changes until the third prototype. By the time the investigation wrapped up, the second airframe was already almost completely assembled. On January 9, 1944, the second Ascender took to the skies for its maiden flight. Structurally, it was almost a carbon copy of the first prototype. The engineers only made a few minor tweaks to the flight controls, slightly modifying the wing stabilizers. Because everyone was still wary of a repeat of that deadly flat spin, the test program imposed strict limitations. Pilots were strictly forbidden from performing any aggressive maneuvers below 20,000 feet. They were also ordered never to let their airspeed drop below the minimum controllable airspeed. The specific fixes applied to this second airframe included enlarging the elevator and modifying its trim tab system. Engineers also swapped the aileron balance tabs for a different spring tab design, hoping to give the pilot a more predictable feel through the stick. On April 25th, the third prototype of the unusual XP-55 fighter joined the flight test program. This took place at the Army Test Center at Wright Field in Dayton. This aircraft had been heavily modified based on recommendations from aerodynamicists. Specifically, designers increased the wingspan by almost 4 feet. The nose of the airplane finally housed its full combat arsenal. It was equipped with 4 M2 Browning 50 caliber machine guns. Each gun carried 200 rounds of ammunition. Beyond the extra wingspan, the third prototype also picked up small auxiliary trailing edge control surfaces, mounted just outboard of the wingtip rudders. These fixes were the direct result of lessons learned from the loss of the first prototype, lessons that had simply come too late to make it into the second airframe, which was already too far along in construction by the time investigators finished their report. All previous restrictions on the pilots were lifted, and the team resumed spin testing. Even though the overall flight characteristics were considered acceptable, the airplane still lost way too much altitude when recovering from spins. On top of that, the larger forward elevator area made the fighter overly sensitive to stick inputs. Because of this, keeping it stable in flight became a whole lot harder. Just trying to trim the aircraft for level flight, a pilot could accidentally lose control and pitch down into a steep dive. By the time testing wrapped up, the numbers told their own story. Fully loaded for combat, an XP-55 weighed close to 8,000 pounds, yet its top speed topped out at only around 390 miles per hour at 19,300 feet, a far cry from the 500-plus miles per hour the original design studies had promised. Its normal range with a full fuel load came out to roughly 635 miles at a cruising speed of about 296 miles per hour, and it could reach a service ceiling of 34,600 feet. Climbing to 20,000 feet took just over 7 minutes. Simply put, these were not competitive numbers against frontline fighters like the P-51 Mustang or P-47 Thunderbolt, aircraft that were already flying combat missions overseas. Another really dangerous trait of the Ascender was that it gave the pilot practically no warning before a stall. The airframe buffeting you would normally expect approaching a stall was barely noticeable. This made flying it incredibly risky. Adding to the long list of problems was the notoriously poor engine cooling. In the fall of 1944, the second prototype was upgraded to match the third. Both airplanes were fitted with artificial stall warning systems, but the test pilots themselves thought these devices were unreliable and largely ineffective. In November of 1944, the third XP-55 was sent down to Eglin Field for gunnery trials. Tucked away in the Florida Panhandle, Eglin had long served as the Army's primary site for evaluating aircraft armament, giving engineers a chance to see how the Ascender's 4 machine guns performed under realistic firing conditions. Just a month later, the fighter came right back to Wright Field, but by that point, the entire XP-55 development program had been officially shut down. The world was standing on the edge of a new era, the jet age. It was pretty obvious that such an exotic and incredibly temperamental piston engine fighter just did not stand a chance against upcoming jet aircraft. Some designers still tried to save the project by pitching the idea of retrofitting it with a jet engine. But the military did not back the idea, since spare jet engines were still in critically short supply at the time. Despite the project being canceled, the Army Air Forces decided to show off the third XP-55 to the general public. This event took place on May 27, 1945, during a massive airshow at Wright Field. A huge crowd gathered to see the spectacle. By some estimates, attendance hit 100,000 people. That day, you could see practically every major type of combat aircraft from that era up in the air. Flying overhead were giant C-46 transports towing troop gliders, legendary B-29 heavy bombers, and even one of the first P-59 jet fighters. The airshow was officially billed as the 7th War Bond Airshow, part of a nationwide effort at the time to sell war bonds to the American public even as fighting in the Pacific ground on. These aircraft were flown by absolute legends, famous American aces. For example, the P-38 Lightning was flown by the top-scoring American ace of World War II, Major Richard Bong. He had an incredible 40 confirmed kills to his credit. The sleek P-51 Mustang was piloted by the renowned Dominic Tilly Gentile. He had scored 22 aerial victories. The organizers had put together a truly spectacular lineup for the crowd. The plan called for a 5-ship formation of completely different fighters. They were to fly in a tight V formation at an extremely low altitude right in front of the grandstands, and then simultaneously execute a barrel roll. Leading this unique formation was the XP-55. In the cockpit was a highly experienced pilot, Captain William Glasgow. He was a genuine hero. He had flown over 80 combat missions in the skies over Europe and North Africa. He earned numerous prestigious awards, including the Silver Star, the Distinguished Flying Cross, and the Purple Heart. His military record read like a movie script. On his final combat mission, Glasgow was shot down, wounded, and taken prisoner by the enemy. He managed to escape, was eventually recaptured, but then escaped a second time. Relying entirely on his survival skills, he made it back to friendly lines on his own just 2 weeks later. During the demonstration itself, everything went exactly by the book. That was right up until it was time to execute that barrel roll. Tens of thousands of spectators held their breath. They watched the XP-55 begin its barrel roll, but immediately after, it suddenly began rocking violently from side to side. The fighter started losing altitude fast. It clipped a fence, instantly burst into flames, and disappeared into a thick cloud of black smoke. The sheer force of the impact threw Captain Glasgow from the cockpit, killing him instantly. Carried by its momentum, the burning XP-55 skidded across the ground and slammed into a parked car. This horrific freak accident claimed the lives of 3 bystanders, a man and 2 children sitting inside the vehicle. This tragic crash put a definitive end to the story of the Ascender. Counting the original CW-24B testbed alongside the 3 armed prototypes that followed it, 4 different Ascender airframes had taken to the sky across the whole program. By the time it was all over, exactly half of them had been destroyed in crashes. As for the second XP-55, it miraculously escaped destruction. It survives to this day. Its own flight test career had wound down quietly by comparison, ending on April 21, 1945, after logging a total of 27 flight hours. That May, the Army flew the airframe to Warner Robins Field in Georgia, then later moved it on to Freeman Field in Indiana to await its transfer to the National Air Museum, the predecessor of today's National Air and Space Museum. By July of 1946, it had reached the storage facility at Park Ridge, Illinois, the start of a long journey through the Smithsonian's collection system that would eventually secure its place in the National Collection for good. It is now on display at the Smithsonian's National Air and Space Museum in Washington, D.C.